What happens if there's no resistor in the circuit? Should I connect these wires over here? Don't do it. Do it. Don't do it. Do it. You ready? Oh, bad things happen when you do that. Bad things happen. Split the junction. Okay, so yeah, if there's no resistance, then that battery tries to flow infinite current, right? And it can't. So it tries to flow as much current as it can, and basically it burns itself out. And hopefully before it catches on fire like that. Okay. Very good. The next row, did you do? Let's try to get through this worksheet, and then we'll take a short break. Potential difference between points N and M for those three cases. What do you think? Talk it over real quickly. How about A? What's it going to read for case A? Yeah, we just did that one, right? That was D in the previous example, right? We just did that one. This one, we said it was the battery. That's the same thing here, right? It's the battery. This is connected to this side of the battery. This is connected to this side of the battery. It doesn't matter that charges are flowing. How about B? Same thing. Less charges are flowing now, right? Because there's bigger resistance. There's two resistors here in series instead of one, so less overall current flowing. But we're just hooked up to each side of the battery. How about here? Same thing. You're reading the voltage of the battery, and there's even less current flowing. Let's see. I've set it up here. This one was the first case that we've already checked. So you're just reading the 9 volts of the battery. And then up at the top, I have 2 light bulbs hooked up. And we're reading the voltage of the battery. And if I put a third one in there, we'd still be reading the voltage of the battery. Less current. You see the little charges aren't moving as quickly up there as they are down here. Less current flow. That's how they show current flow. All right, and then the last one here. So what do you think the voltage is going to be in this case? If it's a 9-volt battery, 3. We agree? Because what are you reading? You're reading the voltage drop across this resistor, right, across that light bulb. Those resistors are all identical. So whatever you have, whatever voltage the battery is supplying, 1/3 of it is going to drop across the first resistor, the first light bulb. 1/3 will be on the second, 1/3 will be on the third, because those are all the same resistance. If they had different values of R, it wouldn't be the 1/3, 1/3, 1/3. But since they're all the same, it's going to be, because this is the other way to look at it, they all have to have the same current flow because they're in series. They have to have the same current through them. And they all have the same resistance. They're identical. So V equals I times R. The voltage across each one has to be the same. And you add up the voltage drop across the first one, plus the second one, plus the third one, and what do you get? The battery. You could think about elevations again. The battery is an elevator. It takes you up 6 stories in a big building. Now we come down through 2, come down through 2, come down through 2. We're back to the ground level, or I guess I should be going this way, shouldn't I? We go up, we come down, down, down. We're back to where we started. Should we check it? It's the top one here. So if we hook up across just the first battery, just the first light bulb, we get a 3-volt drop. If I hook up just on the second one, I'm moving both probes, so I'm just measuring across the second resistor, the second light bulb, I get 3 volts. And if I do the same thing over here, I get 3 volts. And if I pick 2 light bulbs, what do I get? 6 volts, right? There's a 6-volt drop between those 2 light bulbs. And if we do all 3, we already said we get the battery. We're measuring the battery now. All right. Let's take, how about a 5-minute break? Is that okay? A quick break, stretch our legs a little bit, and then we'll get back to this.